Hi there. If you're like me, then you like building user interfaces that behave exactly the way you want them to. And the Unity engine's built-in scroll view is a great start, but has some default behavior that I don't care for. In this video, I'm going to show you 5 simple improvements to up your scroll game. All necessary code will be provided. You can download it from my GitHub linked in the description. All right, here in Unity, let's get our example scene set up real quick. All I have is just a canvas. Under this canvas, I'm going to create the default scroll view template here. So right off the bat, let's make this a little bigger. I'm just going to scale it up on the X and Y by 2, just so that both the scroll view and the scroll bars are a little bit more visible. On the content, I'm going to add a vertical layout group component. We'll set that to upper center, turn off child force expand, and then we will add a content size fitter with vertical fit set to preferred size. So that will just arrange all of the items we place in the scroll view to stack vertically into a nice list that we can scroll around on. I also created a scroll item here. This is just as simple as an image with a text element on it, just so that we can actually put something in our scroll view. So I'm going to make a duplicate of that and place that as a child of content, and now make a bunch of duplicates of that. So now we actually have content in our scroll view. Let's also make our scroll view a little bit taller. So I'm just going to go to the rect tool and then increase the height of that. Let's play, and we can see that we have a perfectly functioning scroll view, which we can scroll with the scroll wheel very slowly, or we can grab the scroll bar on the side here. So just a couple of changes I'm going to make. On this default ScrollRect component, I'm going to increase the scroll sensitivity to 30, because otherwise it is dreadfully slow by default. I'm also going to turn off horizontal scrolling, because this is just going to be a vertical list. So we can just uncheck that there, and then I'll go ahead and set the horizontal scroll bar inactive. Oops, I can't do that. First, I have to set the horizontal scroll bar to null, and then I can deactivate the horizontal scroll bar there. Okay, so this is our basic scroll bar. But right away, I can see the first problem that I have with the default scroll wheel, which is that you get conflicting behavior between the scroll wheel input and the dragging input, right? So like I can click and drag to move our items, and then while doing that, I can still scroll the scroll wheel, and you see how it like jerks, because like it is processing both the dragging and the scroll wheel input at the same time. I find that quite awkward, but it's a very easy fix. I'm just going to create a new script. We'll call it custom ScrollRect. Open that up in Visual Studio. We can go ahead and get rid of the start and update method. And right off the bat, we're going to need to add 2 namespaces. We're going to need unityengine.ui and unityengine.eventsystems. Further, let's inherit from the ScrollRect class, because we're essentially just extending the existing functionality. To have access to that scroll event, as in scroll from the scroll wheel, we're going to write public override void on scroll. So this is the event that fires when you have that like scroll wheel input. Our solution here is going to be as simple as getting the velocity property from the ScrollRect and just resetting it. So we can set it to vector2.0, because it is a vector2 holding like the vertical and horizontal velocity of that drag input, and we're just resetting it out to 0. If I give that a save, head back to Unity, we're going to have to swap out our the default ScrollRect for our custom ScrollRect. Remove the ScrollRect, drag on our custom ScrollRect. Oh, can't be found. I'm going to right click, re-import. Okay, that seems to have fixed it. So let's just reset up this component. So for the content object, we can just drag that one in. I'm turning off horizontal scrolling. Let's see, scroll sensitivity, let's turn that back to 30. Drag the viewport back in, and then drag our vertical scroll bar back in. So now that we've done that, let's play. And once again, I'm going to drag, but now I'm going to scroll while in that like inertia from dragging. And you're going to see that as soon as scroll wheel input has been brought in, it's going to cancel out the momentum like from clicking and dragging. So you can essentially only have one input at a time. So you don't get that awkward jerking anymore. For our second improvement, I'm going to show you this horizontal scroll view that I created for my game. So we can drag to move it left and right, as you'd expect, as well as the scroll bar, but we can also scroll with the scroll wheel. But I don't really want the scroll wheel to scroll our scroll view left and right. I would rather maintain that for like vertical scroll bars and just force the user to drag or use the scroll bar for that input. This just sort of feels awkward to me. So essentially all I want to do is just add a little toggle to disable the scroll wheel input from working on our ScrollRect. Switching over to Visual Studio, let's just create a new variable. So we'll say serialized field, private, bool, and we'll call it prevent scrolling. And in our onScroll event, we'll just check if we are not preventing scrolling, then we can go ahead and do that scroll behavior. However, when we head back into the editor, we'll have the problem of our bool is just not available. And this is because the ScrollRect class has a custom editor script that is overwriting and creating like a custom drawer for the component. Our bool is just never being rendered. So we're going to need to make our own editor script to override the overriding. It'll be simpler than it sounds, I promise. If you've ever used editor scripts before, you'll know that you have to put them in a folder called editor. So I'm going to create a new folder, call it editor here. And inside that folder, I will go create C# script. We'll call this custom ScrollRect editor. We can get rid of the update and start. We can also get rid of these namespaces because we're going to need to do using Unity editor. We're also going to need Unity editor.ui. And with Unity editor.ui, we can do inherit from ScrollRect editor. So that is the script in the Unity UI that is making that custom property drawer. We're going to need to add an attribute, custom editor. We're going to say type of custom ScrollRect, as in the name of our custom ScrollRect. And once we've done that, we need to define a serialized property. We'll call that the prevent scrolling because that is the property we're trying to serialize. To get access to that, we will override the on enable. So after the on enable, we'll say prevent scrolling equals serialized object dot find property, and then we'll say prevent scrolling. And this will just set our serialized property to the one we defined over here. There is one little improvement we can make, though, which is that right now we're checking by string. If we were ever to change the name of this serialized property, then it would break this find without like an error. So we can instead do name of, and then just copy and paste in our prevent scrolling. And that way it'll just use the string of the name of it so that if we ever were to like change this, it wouldn't, it would give us an error. So we wouldn't it wouldn't break without us knowing why. Now that we've done that, we need to override our on inspector GUI. So that's when it is actually creating like the component in the inspector. So we will do serialized object dot update first. Then we can do editor GUI layout dot label field. And then I'm just going to call this custom ScrollRect options. This is essentially just a header in our component for clarity. So we'll say editor styles dot bold label. And then after that, we need to draw our property. So we'll say dot property field and prevent scrolling. Okay. And then finally, we do serialized object dot apply modified properties. I'm going to save that. I'm going to go to our scroll view, and just like that, we now see our prevent scrolling variable being serialized in the inspector here. So tick that on, play our game, and now I am scrolling the scroll wheel and no scroll is happening. So for our third improvement, let's just retrace our steps on that last one and add an option to prevent dragging instead. because I'd say it'd be pretty common for you to want the scroll wheel behavior and the scroll bar behavior, but not the dragging behavior, because that is kind of unusual on like a desktop app. Back in our custom ScrollRect class, we are going to do public override void, and this time we're going to do on begin drag. So that is the equivalent event to unscroll, but for dragging. And very similarly here, we're going to create a new variable. We'll call this prevent dragging. And then very, very similar to before, we'll say if not prevent dragging, then do the on begin drag. It's that simple. However, we will need to add this new variable to our custom ScrollRect editor. We'll make a new serialized property. Call this one prevent dragging. We need to find it in the same way. So we'll just duplicate this and then copy in the prevent dragging, name of prevent dragging. And then where we are putting in our property field, we will duplicate that and then put in prevent dragging in there as well. Save both of these back to Unity, and we have that option. To demonstrate the next improvement we're going to make, I have built our simple scroll view to an Android phone here. There is a problem, which is that, let's see, I'll start scrolling to the right with one thumb, but I'm going to grab with the second thumb and pull in the other direction, and we'll start to notice this weird, like, jittering fighting behavior, because it is sort of processing that drag on both inputs at the same time. So scrolling with multiple fingers leads to all sorts of weird behavior. To be honest, this is actually a really easy fix and something that seems like it should be built in from the get-go. So there are going to be a couple different ways to fix this problem. One way could be to only use the first touch, as in the first finger that begins scrolling on that ScrollRect is the one in charge. That could be a way to do it. But the way I want to do it is to have the last finger, as in the most recent touch on that ScrollRect is the one that gets to control it, and only that one, so that you don't have that jittering fighting behavior. So to do this, we're going to cache our active pointer ID, that pointer ID being a unique identifier to each touch. So we'll say private int, we'll say active pointer ID. We'll set that to -1 by default. And then we're going to check what that is on a new override. So we'll do public override void on initialize pointer drag. In this one, we're going to get the active pointer ID. So we'll say active pointer ID equals, and then in that event data, from the pointer event data, we'll say dot pointer ID. So what this is saying is every new potential drag, we are caching that active pointer ID. Then back into our on begin drag, we can say if we're not preventing dragging, right? That's the first thing. But then also we need to check if the event data dot pointer ID matches our active pointer ID. So it's only going to begin drag if the drag is coming from the most recent potential drag. We can also do public override void on drag and do the same thing in there where we'll just check if, let me scroll this up a little bit, if event data dot pointer ID is equal to our active pointer ID, only then do we commence the drag. Finally, we're going to need to reset that active pointer ID when a drag has finished. So we'll do public override void on end drag. And as usual, we will check if the pointer ID of this one matches that active pointer ID. And if it does, we will commence the ending of that drag, but then we will set our active pointer ID back to -1. These pointer IDs will always be a positive integer, so by setting this to a -1, we're just ensuring that it's never going to match that active pointer ID. All right, back on mobile here, we can test out our new changes by beginning a drag with my right thumb and then continuing this drag with my left thumb. Look at that. It transfers ownership of the ScrollRect to the left thumb. Right thumb goes back on. It's now back on the right. The left thumb has not left, but we can move it back and forth all we want. It's not going to do anything because ownership is on the most recent input. I really think this should be the default behavior, but oh well, it's pretty easy to implement. All right, we're over the hump. There's just one last improvement that I want to make to our scroll views. So this behavior here, this elastic movement type that we can control by setting this to elastic or even clamped. So clamped is going to have it just stop hard once it hits the edge of kind of the, the scroll view area. And then elastic has it stretch and then snap back into place. That elastic behavior, I think, is great on touch screens. Like iOS and Android have that behavior built in. But like on a PC here, it kind of doesn't really make sense. And when you scroll on the scroll wheel kind of against one of the edges, kind of fights you, doesn't really feel good, doesn't really look good. But it would be such a pain to set each of these components to elastic every time you build for iOS or Android, or set it to clamped every time you build for PC. So let's just handle that automatically. In our script, let's add back our start method. That's going to be a override of the start method since we are inheriting from the normal ScrollRect class. Anyway, so to detect whether we are on iOS or Android, we will use a preprocessor directive. We're going to say hash if Unity underscore Android, and we'll say or Unity underscore iOS, and then in here we can define Android or iOS only behavior. So we'll say movement type, that's a property of the ScrollRect, and we will set that to movement type dot elastic. Then we're going to do hash else. So if we're not running on one of those platforms, we will say movement type equals movement type dot clamped. And this is grayed out because we are currently set to Android. So this code is just not going to run. And then we finish it off by going hash end if. We play, and now we have that elastic behavior, but that is because my build target is set to Android. So I'm just going to quickly switch this over to Windows, Mac, and Linux. All right, that's done. So play, and just like that, we are on clamped. So if we go to our custom ScrollRect component, we can see that it's just been set to clamped. You could set up a more sophisticated version of this where you have, control for that right in the inspector, but I'll leave that up to you. One other thing you might want to do is, so right now it's changing based on which build target I have the editor set in, but you might want the, PC behavior in the editor since the editor is always going to be running on a PC. So if you wanted to do that, then you would edit this conditional to be if Android or iOS and not Unity underscore editor. So that's, as you can see, it's now highlighted the clamped line because this is no longer true, right? We are in the editor, so we're only running the else version of this conditional compilation. And after all that, we now have our evolved and improved version of the ScrollRect. There are a bunch of other improvements we could have made, so if you have any good ideas, let me know in the comments, and I'll see you next time. Happy scrolling.